How does the Linux kernel run on so many devices? Have you ever wondered how the Linux kernel manages to operate on such a wide variety of devices? From tiny gadgets to powerful servers, the Linux kernel is everywhere. Let's break down how this is possible. First, the Linux kernel has a modular design. This means it can load and unload different parts as needed. Instead of cramming every possible driver into one big package, it keeps many of them as separate modules. When a specific device is connected, the kernel can load the right module to make it work. This flexibility allows Linux to support countless hardware configurations without bloating the core system. Next, the kernel organizes its code smartly. It separates architecture-specific code from machine-specific code. This means that different types of processors, like x86 or ARM, have their own tailored code. When the kernel is compiled, it only includes the necessary code for the target device. This targeted approach helps Linux run efficiently on various hardware. Another key feature is the unified device model. This model allows the kernel to representing all hardware devices using standard data structures. Each device connects to a bus, like PCI or USB, which helps the kernel discover and manage hardware consistently. This means that no matter what platform you are using, the kernel can recognize and interact with the devices in a similar way. For embedded systems, the Linux kernel uses device trees or advanced configuration and power interface tables. These tools describe the hardware layout, allowing the kernel to understand the configuration at boot time. This way, new devices can be supported just by updating the device description instead of changing the kernel code itself. Memory management is another area where the Linux kernel shines. It supports complex memory architectures, including systems with virtual memory and non-uniform memory access. For smaller devices, there are versions like Micro Linux that can run on systems without virtual memory. This adaptability means Linux can reach a wide range of devices, including very small ones. Customization also plays a role. Different Linux distributions often modify the kernel to support specific hardware or features. This can include adding drivers or patches that might not be available in the main kernel. As a result, each distribution can cater to its target audience, further expanding the range of devices that can run Linux. In practical terms, you will find Linux running on desktops, servers, embedded systems, mobile devices, and even supercomputers. Each of these environments benefits from the kernel's adaptability and modularity. On desktops, it supports various CPUs and graphics hardware. On embedded systems, it is often streamlined to include only the necessary components. The Linux kernel's ability to run on so many devices comes down to its flexible architecture, smart code organization, and a robust device management system. This makes it a popular choice across different hardware platforms, ensuring that it remains a key player in the operating system world.